In this problem, x and y are two real numbers, and we will prove that x squared plus y squared is equal to 1 implies the absolute value of x plus y is less than or equal to square root of 2. So how we will do? The first thing is we will prove that 2x squared plus y squared is greater than or equal to x plus y squared, and we will do it by just making the difference. So we have 2x squared plus y squared minus x plus y squared is equal to, here we distribute 2x squared plus 2y squared minus, and here we have a special product, x squared plus 2xy, of course, plus y squared, and of course it's equal to 2x squared plus 2y squared, and here we distribute the minus x squared minus 2xy minus y squared. Here we have 2x squared minus x squared. It's of course x squared. And here we have 2y squared minus y squared, which is of course plus y squared. And here we have minus 2xy, which is of course equal to, here the special product, x minus y squared. And since it's a square, that means that it's a non-negative number. So this difference is a non-negative number, meaning that our inequality holds. Now back to our problem. So from here we have x plus y squared is less than or equal to 2x squared plus y squared. But x squared plus y squared is just equal to 1. So here it implies that x plus y squared is less than or equal to 2 times 1, which is 2. And by square rooting the two terms, we will have the square root of x plus y squared is less than or equal to the square root of 2. But we know that the square root of a squared is just the absolute value of a. We know this. So from here we have this term is equal to the absolute value of x plus y, which is less than or equal to square root of 2. And this of course concludes our problem.